Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with MetaGeek. Today's host is Adam Medema. He is their product manager, and he'll be presenting today. If anyone has any questions, please feel free to submit them in the question box, and Adam will answer them at the end of today's presentation. Adam, I am finished for now. Thank you so much for being with us today. So you can go ahead and take it on over.
All right, great. Thanks, Julie. Hi, this is Adam Medema again at MetaGeek. I am a product manager. And one of the last things that I was responsible for being a product manager for was the Wi-Spy Air and the Air Viewer application. And so today I've wanted to give you guys a presentation of what the Wi-Spy Air is and how the Air Viewer utilizes that new piece of hardware to show some awesome Wi-Fi information. So I'm just going to go into the next slide here. And so I want to show you guys what the Wi-Spy Air looks like. So on the right, if you're ever just curious what your presenter looks like, well, that's me just throwing around the Wi-Spy Air. So it also gives you a good example or a good idea of what the size of the Wi-Spy Air is. It's, pretty small. It's easily held in your hand. And then on the left, I just want to show you guys the different parts of the Wi-Spy Air. At the top, of course, you have your antenna. And on the right side, you see this little port right here. This is a charge port, which has a USB micro connector in it. And so one of the main differences between Wi-Spy DBX or the previous Wi-Spis and the Wi-Spy Air is that the Wi-Spy Air has a wireless chipset in it. So it's not only a dual band spectrum analyzer, but it also has a wireless chip in there. So we could just observe the packets going through the air and analyze the packets to be able to present the data that we'll see within the Air Viewer system. But because we have another chip in there, that caused some more requirements for extra power to be able to drive that Wi-Fi chip. And so on the very back, you can't see it in this picture here, but there's a spot where you could put in 4 AAA batteries. And within the package that you receive, if you do purchase a Wi-Spy Air, we include the batteries and any other cable that would be necessary to charge the batteries within the unit itself, as well as the different device connectors to an Android or to a iPhone or to a computer via USB-A. But I just wanted to show you that here because this is where you would plug in the cord to charge the onboard batteries. And then on the bottom is where you would plug in to connect to your actual device. And again, all the cables that you would need to either charge the rechargeable batteries that are provided, as well as to plug the Wi-Spy Air into your device are included within the kit. And so that's just a general overview of the hardware. And now I want to take you into the software. So I'm going to go and get out of this actually. And then on my other screen here, I'm just going to pull this over. And so I have connected to my computer this tool that allows me to basically project my phone onto my computer. And I have an iPhone in my hand, and I'm just plugging in the Wi-Spy Air into it. And we can see that it's getting ready to go. And now it's going to start scanning my home environment. So I'm actually at home right now, working from home today, and it's doing a scan of my home environment. Within the Air Viewer, every time you see this little blue swirly thing on the top right, it's doing a Wi-Fi sweep. And this is the main screen that you'll see once the Wi-Spy Air Viewer application is launched. So it's basically, hey, here's the different networks that I can see across the different bands, and a list of all the different networks that the Wi-Spy Air is able to pick up. And then if your device is actually connected to a network, you'll see the little chain link icon appear right next to the SSID. And so my home network, I named it Coda after my dog. And if you click into that, you'll get more details about your home network or whatever network you're connected to or whichever network you want to drill down into. And so this will give you a lot of just high-level information about that network. And if you scroll down, you can see the different BSSs that are broadcasting on your network. So at my house, I just have one physical box, and it's broadcasting both on a 2.4 radio and a 5 gigahertz radio. And so I see those BSSs broadcasting here. And then if I clicked on the clients tab, this will show me client information. And so you can see that I have observed via the Wi-Spy Air 10 different clients at my house at the location I'm currently at. So if I scroll down, I can see what those are. So I have a couple Sonos players at my house to play music. I got an Apple laptop. All of our phones are Apples. So it's probably a lot of what you're seeing here. You could even see my Nest, which is kind of cool to see that. And then I want to go back here and show you again the main networks tab. So if you're doing just like general planning and walking through an environment and seeing what kind of channel that you might plan for at a particular environment, if just looking at this view, you might think to yourself, well, 6 and 11 look pretty good because there's not a lot of interferers over there. I mean, you might have one adjacent channel interferer at what looks like channel 9 or 10. But this is only giving you some of the information. So the great thing with having a spectrum analyzer chipset on board is that you could also see the spectrum analysis for that whole entire band for 2.4 and for the different 5 gigahertz networks. So when I switch over here, I could toggle my networks on and off, but I could see that there's just a lot of just interference going across the whole entire band. And so without having some kind of spectrum analyzer, you would never be able to see this type of activity going on. And this is a lot of activity. And there's actually a pretty good reason for on the 2.4 gigahertz that I have this activity going on right here. I mean, you can see on channel 1, there's a pretty strong network, looks like a typical Wi-Fi AP chattering. But on the rest of the band, it looks just like a bunch of stuff, really the whole entire band. And the reason for that is because right next to me, I have my baby monitor. So I have about a 5-month-old, and with a 5-month-old, we always want to have a baby monitor in our hand to see if the kid is, doing well, if he's sleeping or if he's moving around or if he's chatting or anything like that. But a lot of what you see right here is mainly because of that baby monitor. And so I just turned it off. And now that the baby monitor is completely off right now, you can see everything is kind of leveling out. So instead of just all that racket going on across the whole entire 2.4 band, everything died down, and now you can see more of a, like a good looking environment where, hey, channel 6 and 11 don't look so bad now because there's less activity going on. But when the baby monitor was on, you could just see all that activity. And that's something that you would just be able to see with a spec DAN. And I got another little example too. I have a old 2.4 gigahertz digital phone in my hand. And so if I turn this guy on, we'll see pretty much right away that it just becomes this major interference on around channel 3. And so that's going to interfere with my network, my home network that's using channel 1 as well as some of the other networks. So, this kind of information is only really visible with a spec AN because it's, non-Wi-Fi interference. It's not the typical just Wi-Fi interference that you would see within a typical just Wi-Fi scanner that shows you the different SSIDs and networks, but it's this non-Wi-Fi stuff that's just still within that range that's causing interference. So I'm going to turn that off. And another example I want to show you guys of interference is right here. So I'm going to push this over to the side. And so MetaGeek is headquartered in Boise, Idaho. And a lot of the testing that I was doing as we're developing the Wi-Spy Air and the AirViewer application was really just at different local places around here in Boise. And one of my favorite places to go test was at the Whole Foods that we have downtown here. So usually I would just, walk over there for lunch and get a lunch at the lunch bar and then walk around Whole Foods afterwards to see what they had going on at Whole Foods. And it's actually a pretty cool place to do some testing because they actually have a lot of APs. They have about, I think like 12 or 14 APs just on the floor there, which seems like quite a bit. But it still allowed me to be able to test AirViewer in an environment that that has a lot of APs, whereas our office or my home just has a couple APs. But with all that being said, one time, and this is kind of a cool thing about Wi-Spy Air is that since it's so portable, I was just walking outside of Whole Foods and I was walking towards the green belt, which is right next to the Boise River. Here's a picture that kind of gives you a sense of what that looks like, where you have this walkway right here, and to the right is a bunch of trees, but directly to the right of the trees is the Boise River. And to the left here, you can see Boise State University. And when I was walking down this path, I just saw like this really big noise floor, which you could see represented in this picture right here, where a lot of times for 2.4 LC, kind of the noise floor hitting around -100, but this was going a lot higher, up around -90. And then I noticed this as I was walking out of Whole Foods, that the closer I got to the Boise River, the higher the noise floor was getting. And then the further down the Boise River I was going, the lower the noise floor was going. And so I was kind of thinking to myself, well, I wonder where that even comes from. And so the following day, I got a directional antenna, and I put the directional antenna on the Wi-Spy Air and did a walkabout. And then I was just walking around that general area, trying to see what was causing all this, this noise, this high noise for the 2.4 band. And then I pointed to in such a location where I saw all these towers on top of this hill. And, I was thinking, well, maybe that's where all that noise is coming from. And so the next day I went up to this hill right here. It's called Table Rock in Boise, and took some pictures of downtown. So this is downtown right here, and I was probably in this area right around in here. And I was looking at these big towers. And so these towers are really high up, and they're point-to-point parabolic dishes. And so I had the directional antenna and I was trying to point to them to see if I could capture any noise, but I think I was just outside the Fresnel zone, so I wasn't able to capture too much. And then I saw this little guy up here, which was pretty interesting, seeing a radio frequency environment area notice sign. I just thought that was kind of funny. But then I saw this one where we had a bunch of lower antennas that I could reach up and capture more stuff with. So I was just kind of interested to see what was going on there. So I captured a video, which I'll play here, and kind of just see that, like whatever's going on is just kind of spurting out these really quick spurts in different areas of the 2.4, and sometimes it seems like everything on the 2.4 range. And then, it kind of looks like a dance after a while of just this stuff, intermittently going off. And so it's, pretty interested to look at this while it was going on. And was able to determine that, yeah, if all this stuff going on up there, and then with all these parabolic dishes basically pointing to downtown Boise, that, yeah, within that space where I had kind of a nice line of sight with these towers, that this was more than likely causing that high noise floor. And so it's pretty interesting seeing it dance around in 2.4 range, and then I'll just scooch over a little bit and we can see how it goes in the 5 gigahertz range too, because this was also broadcasting on the 5 gigahertz range channels as well. So you can see it just kind of go up on the 5 gigahertz range there. So I thought that was, pretty awesome. And again, something that I probably wouldn't see too often, given that a lot of times with the spec an, I would be carrying around a laptop and not a portable device such as just my phone. And we can see that, I don't know where my wireless phone went, but it's still actually broadcasting there and causing some interference there. But luckily, my setup here is that I'm actually connected to the 5 gigahertz band. And so I have a Google Wi-Fi router, and it's broadcasting out on 80 megahertz wide frequency. And so if I go here and look at channel 42, which is the center frequency of that 80 megahertz wide channel, we can see some activity going on. So a lot of that is my laptop, but I also have another phone in my hand, and I'm going to do a speed test. So we could see some of that stuff just chirp. So I'm doing a speed test. Oop, and it looks like it's mostly working off of 40 megahertz, so dynamically shifted for this particular phone. And then I want to show you a little more. So if you drill down into the channels, and look at Coda network right here. And I want to show you what the utilization looks like after running a speed test. And so you see the utilization, which is right around here. It's been going up and it's been going down. And so I'm running a speed test right now, and it's going up to 13%, 11%, because it's dying a little bit. And I'll order this list, which is a list of clients by utilization, high first. And again, every time you see this little blue ring on the top right, it's doing a Wi-Fi sweep. And the way we do Wi-Fi sweeps is we try to do it within the context of the screen that you're currently on. And so in this case, in this BSS ID that's broadcasting on, let's see, channel 42, it's really just going to sweep for that particular channel. And it's not going to sweep all the other channels. So it knows that I'm concentrated on this particular channel, so it's only going to sweep for this particular channel. And then I could see all the different connected devices below. And I'm running another speed test right now. So we could see that for utilization, the Motorola is going up, and it's really just contending against my MacBook right here, which is what I'm using for this presentation. And you can see that there's some retry rates popping up too, because they're trying to work over each other. But this is pretty awesome. If you had high utilization for a device that's just going on, oops, sorry about that. Looks like I got a little Slack notification there. But if you have high utilization for a client device and it's just really persistent, you might be triggered by just seeing this high utilization that you might want to look at that client a little more detailed to see if anything's going on with it, if it's just hogging up the whole entire network, if it's just talking too much, and if it's being to interfere with other ones. This will give you a sense of how much a client is talking for a particular BSS ID. And then if you want to look at more information about that client, you could drill down into the details and see the client details, which include, what SSID it's connected to, what BSS it's connected to, the vendor of that device, the signal strength. So that's the signal strength of the client from where the Wi-Fi Air is picking it up. So it's not the signal strength from the client to the AP, but from the client to the Wi-Fi Air. And you could also see utilization, retry rate, and at the very bottom, the client's roaming history, which is another pretty cool thing, because this will let you see how the client roams if the client is moving through an environment, as well as if a client is static. You can see if it's roaming between two APs and it's just like constantly roaming between them. Maybe there's a problem with the placement, as well if it's preferring to be connected to a 2.4 gigahertz radio over a 5 gigahertz. So it could give you some insight into band steering as well for that particular client. So that gives you a pretty good view of how you could drill down from very high level of just seeing the channel information, the RF, all the way down into the client. And pretty much the same thing with the networks. You start at a high level, and then you could drill down to see the network information. If I was walking around the environment and there's multiple BSSs broadcasting for my network, you could see how they kind of switch off, how one lowers and how one goes up. So you could see if there's good like channel planning, good coverage, and you could also see like the clients that are currently chattering within the space. And then from there, just drill down even more. And then on the settings tab, you could pause the Wi-Fi scanning by clicking the pause button, or if you wanted to reset all the data, you could click this icon right here, which will reset all the data and then basically start you fresh. And then right here for the managed channels visibility, for the 2.4 and 5 gigahertz range, if there's channels that you don't care about because maybe you work in a country where, let's say, 149 to 165 Uni 3s never use, you can turn that off, and that actually does tell the Wi-Fi Air to avoid scanning those channels, so it just concentrates on the channels that you actually care about. And then if you scroll down a little more, there's some configurations for the channels graph. And so when we're looking at spectrum, I was just showing the last 30 sweeps, rolling 30 sweeps of spectrum data, which gives it kind of this real-time feel to it. But you could space that out all the way up to 200 sweeps if you just want to hold on to a longer amount of scans, and that will kind of give the sweeps a little more high fidelity feel to it. But I kind of like just seeing it more in real time, so I keep it lower to 30 sweeps. And then for Wi-Fi scans, same thing on the channels graph. If I was here, I don't like the Wi-Fi to constantly just scan on this particular view. And the main reason for that is because there's some limitation with the air where we basically get either spectrum data or Wi-Fi data at a time through that cord, that connector from the Wi-Fi Air to the device. And so for me, I like to have that spaced out a little more. That way, when I'm on the screen, I could concentrate more just on the spectrum and less about the Wi-Fi just updating on this particular page. But you guys have control over how long of a difference between Wi-Fi scans that you have for that. And so this is really what I wanted to show you guys with the Wi-Spy Air and Air Viewer. But I also wanted to give you guys a preview of what we're working on in terms of our next iteration, what we're currently working on right now. And so with the Wi-Spy Air Viewer, one thing that we heard from our beta testers and some customers is, it's great being able to see stuff, but how do I actually save stuff? How do I create reports off of stuff? So what we're doing right now is we're basically working on a way for you to capture data on the Air Viewer and then to send that to your cloud account. And so we're pretty excited about this. So we're making pretty good progress too. In our beta application, you could actually sign in and you could see some screens that take you through the snapshot flow of being able to capture data to send it to the cloud. I don't have that to show you on my device right now since I had the other application, the one that's available on the App Store right now. So I could show you this design prototype on Figma, which basically you can see that we moved some stuff on the bottom tab around a little bit. So we put our settings under this hamburger menu here, and then we put this little snapshot icon right here in the middle of the bottom tab. And so this allows you to click on it and then create a site name. This is the current location that you're at. This is a primary network. This is the description of that site. And then after that, create a room. So at MetaGeek Office, I want to create a room for my desk. So that's a particular location, and I got to write a description about that as well. And then click on done, and then boom, you take a snapshot. So what that does is it collects all that network information that the Wi-Spy Air picks up that you can see in the Air Viewer, and it's going to package that and send it to my cloud account, which is pretty awesome. And so to see what that looks like within our cloud environment, so if you guys have Insider Plus right now, you could see that we're really iterating on the snapshot feature within the my.metageek environment. So this is, again, some design prototypes of what we're currently working towards. And so if I uploaded a snapshot, I could see a list of the sites here once I go to the snapshots. And then if I click on a snapshot or a site, I'll see all the different sessions that I've taken through time. So I can see the different locations, what the primary 2.4 gigahertz radio was, what the primary 5 gigahertz radio was, and some high-level information that I would be curious about, such as signal and channel utilization. And then again, I could click into one of these particular rooms and see more information about that room's data. So again, I see the strongest APs at that particular location. We'll have some charts to show you some graphical representations of the data that's in there, as well as a network topology, so I could see how all the other APs in my network are looking at that particular location to give you more context about the environment. So this is basically what we're working towards. So if you have Plus, Insider Plus subscription, you'll be able to see some of this there today, although it's not looking like this right now because this is what we're iterating towards. This is a design concept of what we're currently working on. So we're pretty excited that we're getting just more stuff into the cloud. long-term goal and something that we're really driving towards here at MetaGeek is that we have, basically just different applications. We have Channelizer, we have Insider, we have IPA, we have AirViewer, but currently they're all kind of disconnected. They don't really talk to each other, and there's some presence where Insider currently talks to the cloud. What we're trying to do long term is to have more of a connected environment amongst all of our different products. So AirViewer will talk to the cloud, Insider will talk to the cloud. We're rolling in IPA and Channelizer to create this environment where you seamlessly could just work from one product to the cloud to another product, and just be in the same kind of ballpark. Whereas before it's like, well, you have one end product and you go to a completely different end product. There was never really any kind of like integration or collaboration between products, which is what we're trying to do away with and build out this awesome just MetaGeek ecosystem where our products work with each other. And they'll be more user aware because they'll all be based off of the cloud backbone. So the cloud will be able to more intelligently know who the user is, what environment they are, what they're curious about, and to be able to kind of utilize, hey, use this tool, use that tool, sort of thing. So that's kind of the general direction that we're going with MetaGeek, and we're all pretty ecstatic about that direction. And so with that, that's basically my presentation. So I'll push it back over to Julie, and I think maybe we have some questions.
Excellent. Thank you, Adam. Appreciate that presentation and the demo. And yes, I do have some questions. Let's get started with the first one here. Let's see. First question, regarding Wi-Spy Air, any plans of replacing the USB Mini to a more common USB port like a USB 3.0 or micro or USB-C?
No plans at the moment. So that's a question that's come up a couple of times. So we like the Mini just because it's good, solid connection with the Wi-Spy Air. And also there was some talk, I think, with engineers about just real estate and what it would take to do something other than that, like going to a USB-C, for instance. So I don't think that's out of the ballpark for the future. But within the first iteration of Wi-Spy Air, that was discussed, but we liked just the stable connection of having the Mini on the Wi-Spy Air.
Excellent. Thank you, Adam. Next question here for you. Will the Wi-Spy Air capture LAA in 5 gigahertz? If not, will the Channelizer Pro detect LAA and differentiate between Wi-Fi and LAA?
Ooh, actually, I don't think I'm too familiar with what LAA stands for. So I'll defer that question unless they're able to define that for me.
Okay, we'll see. Maybe they'll chime in and let me know what that is. Meanwhile, I'll just go on to the next question. Can this device monitor DFC channels?
Yeah, so if we go back here, and I have it up here, so we have DFC, which is typically within the US 52 to 64, 100 to 144. So the uni, I think that's a 2 and 2 extended. So we're able to monitor those channels. Yeah. So basically all the typical Wi-Fi ranges in the US, we have the capability to monitor those. There's some edge case ones, like I think there was a channel 167, if I'm correct, which is mainly used in India, that we don't have the ability to monitor. But all the other ones on 2.4 and 5 gigahertz, including the DFC channels, we are capable of monitoring those for both the spectrum analysis and the Wi-Fi analysis.
Great. Thank you so much, Adam. Next question here for you. How much data can be logged for monitoring, like site surveys, etc.?
So as long as the app is open, it will hold on to the data unless you close out the app or you select the option to reset the data. So as long as you're moving around an environment, it's going to hold on to anything that the Wi-Spy Air has seen in the past. And so I'm trying to look for an example here. So when it's grayed out like this, it basically just means it hasn't been seen in a while. And so we don't have anything that says, hey, get rid of that data. And I also haven't experienced any kind of like crash or anything like that because of just holding on to a whole ton of data. And so in this particular case, this was last seen about 38 minutes ago, so it hasn't been seen in a while. So it's going to hold on to all the data unless you either turn off the application, reopen it, or if you click on reset. And then in terms of the snapshots that we're working on, most of that data is going to just be relevant to where you currently are. Well, that plus what's in your primary network. So where you're at, and if it has been seen through your walkabout and is on the primary network that you've designated for the snapshot, that data will be sent off to the cloud.
Excellent. Thank you, Adam. Next question here. Can you drill into beacons?
Yeah, so the way that Wi-Spy Air works is actually we're just capturing a bunch of packets, including beacons. So all the management control data frames, we have the ability to basically do a PCAP of that. And then what we do is we just break those apart, and then we pull the data that we're curious about and then present them on AirViewer. So yes, the AirViewer, Wi-Spy Air itself, basically is doing just a bunch of PCAPs. Every time you see the Wi-Fi scan, it's doing a bunch of PCAPs and then pulling out the relevant data that we show in our GUI. And I think an interesting thing is, can we show other stuff from a beacon, such as like country code for an AP? I know some providers or some consultants in Canada or in the UK are interested to see if people are using US APs, which that would be information that's available within a beacon. And in that case, we could pull that out and display that somewhere. And another thing that we're kind of toying with here at MetaGeek is, what if we just like capture the raw beacon for the different APs and then also upload that into the cloud? And that way, if someone wants to kind of drill down further into all the nitty-gritties of a beacon, they'd be able to do so with being able to just capture that within AirViewer and then sending that up to the cloud. So we think that would be kind of an interesting thing that more of the Wi-Fi professionals, like the expert levels professionals, would be curious about and would likely enjoy because it's just more data for them to work off of.
Thank you, Adam. Next question here for you. Was the baby monitor 2.4 or just produces lots of spectrum junk?
I don't know. Let me see. I have it down here. So I don't recall it saying anything on the box, whether it's like a Wi-Fi 2.4 baby monitor. I think what it's probably doing is just producing a bunch of junk, which in that case, I would imagine, isn't that kind of an issue with the FCC? I mean, I kind of just wonder that, and it's kind of interesting to see like how much of a pain baby monitors can be. Like in my environment at home, since my computer right now is on the 5 gigahertz channels, it's not really impacting me and my work working on the computer. But we had a coworker back in the day that was calling in to a meeting, and he was on Google Chat, and he was outside, and so like where he was, he could only connect to the 2.4 radio, and he also had the baby monitor on, which was just completely destroying the Google Chat, and until he went in and turned it off, and it cleared everything up. So it's pretty interesting to see these baby monitors just being little jamming devices on the 2.4 range. But no, I don't see anything specific on at least this particular piece of hardware that I'm holding right now that says, hey, this is 2.4 Wi-Fi compliant or anything like that. I think it's just a little jammer, and it's kind of annoying.
Thanks, Adam. Next question here for you. On the spectrum analyzer, how do you differentiate between 802.11 and noise?
Ooh, that's interesting. So I think you would just have to know what noise from an 802.11 device looks like on a spectrum analyzer. So, it's kind of like a curve shaped over a center channel. It looks like it's 20 megahertz wide, or it has a flat top, because it's using OFDM. It is one thing that we've had some customers ask for is like in Channelizer, we have a list of different signatures, just so they know what to expect in terms of a Wi-Fi interfere, non-Wi-Fi interfere. And so that's something that I am considering in a future iteration, is to see if we could kind of detail that out for people that aren't just familiar with seeing Wi-Fi interference on a SpecDAN, to give them a little more, I guess, knowledge of, hey, this could be a baby monitor, or this could be a phone, or this could be a transmit tower. I think that might be helpful for those that are looking at the spectrum band but don't know what's producing the RF. Is it Wi-Fi, non-Wi-Fi? If it's not Wi-Fi, what might it be?
Thank you for that, Adam. Next question here for you. Is there an analytic tool to see transition from one AP to another while moving across a corporate LAN?
So is there a tool out there to do that?
Is there an analytic tool? Yeah, that's the question.
That's something that we are looking at with IPA and with future iterations of Insider to do a little better. So what we're thinking at MetaGeek is we want to see how devices roam, and we want to be able to more intelligently kind of say, hey, this is when it roamed, and this is from the channel it roamed from, and this is the channel it roamed to, and have multiple Wi-Fi adapters to be able to capture the from and the to channels, and then to have like a better indicator within IPA or potential Insider in the future of being able to reduce the packets that you would see if you open up like a Wireshark or an IPA, and then just to point out the ones where it transitioned from one AP to another. So in AirViewer, we have the history table. So that's not going to give you like a dynamic change, since we only have the one Wi-Fi chip in the Wi-Spy Air. Basically, the way that particular screen would work if you're on it is that once Wi-Spy Air doesn't see that a client is on that channel, on that BSS, it'll do a full Wi-Fi sweep to see if it could recover that client to see if it roamed to a different one. So that's not going to be like an immediate transition, but that's something that we're looking at for some of our other tools that allow you to have multiple adapters that could be able to see that and flag it a little more immediately for those that are trying to troubleshoot roaming.
Thank you, Adam. Last question here for you. Site survey tools, will they be available as part of the Wi-Spy Air solution?
So in terms of a site survey tool, there's no integration with Wi-Spy Air for like a Tamasoft or an Ekahau, if that's kind of like the idea for the question at this moment.
Adam, thank you so much for answering all those questions for us today. And also thank you to everyone for attending today's webinar. And if anyone has any further questions, please feel free to contact your sales rep or email us at sales@microcomtech.com. If you wish to view any of these products mentioned or shown here today, you should be able to visit us at www.microcom.us. And please remember, this webinar presentation has been recorded, and it will be uploaded to our Microcom YouTube channel so you can view it again. Thank you, everyone, for being with us today. Adam, excellent presentation. Appreciate your time and everything today. Thank you. Have a fantastic day.